Hello, my name is Stéphane Bourget. I'm a physics teacher in the Quebec college system. Today I'm going to present you a video about how to set up a table in Excel so that you can plot a graph representing the relationship between the variables that you are uh, measuring in a lab experiment. So the first thing I'm going to do is to open a spreadsheet, and so here you have it. And you see that in the spreadsheet, I have already a table set up, but I'm going to explain you a little bit the context of this table, and then I'm going to finish setting up this table so we can uh, move forward doing the graph that represent the relationship we are looking for. Um, so essentially, the context of this data that you see on the screen is a experiment I did with some students a few years ago. And essentially, the idea was that I wanted to test if a motion of a metal ball on the floor was a constant velocity motion or not. So what we did is that we had a platform onto which we um, let go of a metal ball. And so the metal ball fell down the inclined plane and went off the platform to get onto the floor, and then it rolled for some distance. And so the question was, is this a constant velocity motion or do we have some kind of acceleration? So we had different materials available. We had stopwatches, we have measuring tapes, we had sticky tape, and we had meter six. So we had a whole bunch of things we could use to set up this experiment, to find a way to evaluate if we had a constant velocity motion or not. So what we decided to do is that we put some marks on the floor using the sticky tape, and we place a mark at each meters. So we had a mark at 1, 2, 3, 4, 5, and finally 6 meters on the floor. But of course, the mark that we put there was a sticky tape, and it has some width. So although we could use the measuring tape to evaluate the position with a quite good precision from the instrument, um, because of the thickness or the width of the tape, uh, when we were taking position of the ball at a given moment, it was harder to evaluate. Therefore, we had a bigger uncertainty, larger than the instrumental uncertainty. So that's why that we evaluated the uncertainty at the first meter to be plus or minus 5 centimeters, as you see on the table, and we evaluated that it was plus or minus 6 centimeters at 2 meters, and increasing the farthest we were away from the platform, up to plus or minus 10 centimeters at the 6 meter mark. And it's not only because of the width of the measuring tape, because otherwise we would have got the same uncertainty for all the marks. But the thing is that although initially the motion of the ball was pretty much in a straight line, the farthest away we were from the platform, the more curved the trajectory of the ball was. Therefore, it became more difficult to evaluate if the ball was actually reaching the mark on the floor uh, at 5 and 6 meters, because the ball was more distant from the mark than when the ball was at 1 or 2 meters, you see? So that's how we evaluate the uncertainty. Wanted to know the position when the ball hit the mark. So, uh, so we got those uncertainties, and that's what we've put into the table. And then the other job was to actually take some measure of time for when the ball was passing by the mark on the floor. And we had a few students at each mark trying to spot when that happened. So essentially, we started the stopwatches when the ball fall off the platform, and then we stopped those stopwatches whenever the ball was passing the mark. So students at different marks were stopping the stopwatch at different times, but that gave us the timing of the ball passing by those marks. Um, the reason we did it with multiple students at each individual mark was that this allowed us to decrease or to improve actually the absolute uncertainty on the timing. Because if you do a single measure of time, well, then you have your reaction time, right? And actually you have it twice because you have to start the stopwatch and you have to stop it. So if your reaction time is something like 0.2 seconds, which is quite common, well, then that would mean that your total reaction time for measuring a measure of time would be plus or minus 0.4 seconds. And of course, this value could vary from one person to another, but that's an average. Now, if we take multiple measures of the same thing, like in our case, we took it 4 times, well, then we can use a mean deviation to calculate the absolute uncertainty on the average. And normally that improves the precision of the value of time we're using for calculations and for graphing. So that's what we're going to use here actually to input the absolute uncertainty. So you see that on the table, this part is not complete. So I'll show you at the same time how you can do this, how you can input your values in the table. So the first thing you should notice is that you want to set up a table and then you want to edit it so it is properly formatted and it is nice to present in the lab report. So normally you have different columns, you have different cells, different rows. If you are not used to Excel, you will notice that each cell, which is the little box where we can write something, is addressed with a letter and a number. So the column is represented by the letters A, B, C, D, and so on, and the rows are represented by numbers 1, 2, 3, and so forth. So if you are at the cell that is currently highlighted, that would be addressed as A10. Okay. Now, going back to the table, you want to have a heading for all your columns. So in our case, position is already there. Let's just add the average time because we have multiple measures of time and we want to calculate an average. So let me write average time, and let's put the symbol for this. So that will be T subscript AV. Now, headings should actually be in bold, and you can use the fonts you like, but personally I like serif fonts. It's easier to read, I believe. So I like fonts like Times New Roman or Times instead of something like Arial or Calibri. So it's already set up for me. I know everything is in Times New Roman, so I don't have to adjust this. And going back to my heading here, well, I've written average time, TAV, that's in bold, all right. But the other thing is that variables are put in italics. That's kind of a norm that is commonly respected. So I'll do that here. We don't do that for units, but we put variables in italics. Now AV has to be a subscript, so let me select AV and let me go to, well, let me try to right click, and it doesn't work. So let me go instead to, let's see, edit maybe, not exactly. Let me edit cells. Yeah, So you see, in this case, in the spreadsheets, you have to go to edit cells, and then you can select subscript to have the letters you selected as subscripts. Let me click OK, and now it's fine. Now you see that actually my final column here are spread over 3 Excel columns. So I need here to merge and center. So let me select those 3 cells, click merge and center. Now it's better. You see, it's we can read, it's nice. So that's what you should do. And actually you will understand why I've tried to do a heading over 3 columns, because we do need to put values under this heading, and the values are made up of the value itself and the plus or minus the absolute uncertainty. So that's why I need those 3 columns under a single heading. So let me do the same for the second row of the heading, merge and center, and in that second cell here I'm going to put the units. So that should be on a below the label and the variable of the quantity you're putting there. So that's this thing, the time is in seconds, so that's what I'm writing, and then I'll have the cells to put the values. Now I will have the value itself, as I said, plus or minus the absolute uncertainty. So let me put the plus or minus in a separate cell, because I want to be able to do calculations, and the plus or minus sign is going to be annoying if it's in the same cell as the other stuff. I won't be able to really do what I want to do if I do that. So let me select the central cell. Let me insert symbol. So insert tab, symbol, go to math symbols, and then double click plus or minus, get out of there, and then have it. Let me actually center all those columns so it's nice to see. All right, everything is centered. Now you have this plus or minus. I don't want to do the same process again and again. I'm just going to select that, select the bottom right corner, drag down, and everything is going to be copied. So it's very quick. Now you should also make sure that you have proper borders for your cells. So let me just finish what I started. So you go over here. You can select this borders that go all around the cells that you are selecting. So you do that. Do the same thing here, and the last time. Okay. Now let's calculate those average times and absolute uncertainties. If you use Excel to make calculations, you should if you do calculations to find values that you have to put in a table and you use Excel, you should never use your calculator. You should always use Excel formulas. The reason is that, first of all, it's more effective, it's quicker, but the other thing is that if you make a mistake and then you correct something in your table, well, if everything is programmed in Excel with formulas, well, then everything will be recalculated, adjusted automatically, and that will be very easy to make corrections. It's way more effective. If you input values yourself, doing calculations on your calculator, well, then you will have to do it all over again if you make a mistake. And furthermore, you could make mistakes plugging numbers on your calculator and then put wrong values in your table. So in the case of an average, we could do the whole calculation, but actually Excel has a special formula, special function for averages. So let's use that special function. How do you write a formula in Excel? You go to the cell where you want to input the formula, and you start by clicking equal. That tells Excel that you are going to write a formula. Then you want to write the function you want to use. In our case, we want the average. So that's what I'm writing, average, open the parentheses, and actually here you see the function in Excel that pops up. So that's kind of a confirmation that you have written the right function. Then we need to select the numbers you want to average. So let me select cells from D3 up to G3. Close the parentheses, select or click enter, and you get a value. So that's the average. Now you have to do that for each row, but please don't just rewrite the same formula again and again. There is a more effective way to do it. You just select the cell where you've input a formula, then you right click well, actually you don't do that. You just go over the bottom right corner, you click and drag down, and everything is copied. All right. Now I just have one decimal. It might be fine. It might not be enough. I don't know yet because I don't have the absolute uncertainty. So we'll see later, okay, what we do with those decimals. But for now, let's go to the absolute uncertainty. How do we calculate that for an average? Well, whenever you measure something multiple times, you can use the statistical method, and the one we have seen in class is the mean deviation or the average deviation. Another way that is fine is the standard deviation. It is actually more commonly used, but mean deviation is good as well. It's proper, and maybe it's a little more easier to understand. So let's use this mean deviation. That's what we typically use in this class in college mechanics. So how do you do that? Well, click equal again, and then input the formula. In Excel, the mean deviation is called average deviation, and actually it's not the whole word, the whole expression. It's the special function for that is just AVE-DEV for average deviation. Okay, so that's a shortcut. AVE-DEV. So that's the function. Open the parentheses and then select the 4 values that you want to calculate it for. So select the same cells, close the parentheses, equal, and you're done. Now, again, don't rewrite the formula. Just click the bottom right corner, drag down, everything is copied, and you're done for the values. But hopefully you have seen that we have still some editing to do, because first of all, some absolute uncertainties are not properly formatted because we know that they should have only one significant figure. That's our convention, and we learned in class why it made sense. So that's fine for the absolute uncertainties on the position, but not for what we have on the average time. So the first one decimal, fine, also 1 sig fig. Second one, well, we should have 1 decimal because we want only 1 sig fig. So let's use this little button at the top. That's how you change the number of decimals. This one here, 4 sig figs, we need 1. Well, 1 sig figs means that you are going to end up with only 2 decimals. So that becomes this one, 3 sig figs, we need only 1, so that means we need 2 decimals. This one, 3 sig figs, we need to go to 1 sig fig, so again, well, actually in this case it will be only 1 decimal. And here 1 sig fig means 2 decimals. All right, now are our measures of average time consistent with those absolute uncertainties? Some are not. So here 1 decimal, just like the absolute uncertainty, that's fine. This one is fine too. But here we have 2 decimals, and this average time has only one decimal, so we need to have one more. Now, the idea here is that we should never add zeros because, I mean, we cannot invent digits to add to a value that is written. Normally, we can cut non-significant figures, but we cannot invent new significant figures. So actually, what you should do here is just increase the number of decimals because probably the calculation has more digits. So let's use the other icon that you have at the top to increase the number of decimals, and you see that here I increased the decimals to 2 decimals, and now it's consistent with the absolute uncertainty. And you know, the one that just appeared is just a digit that comes from the calculation. Okay, I'm not adding a invented zero. I just add the digits that would normally be there if I kept a lot of extra digits after the decimal point when I did the calculation. So same thing here. Let's add one decimal, 0.75, and same thing here, one more decimal, and that's 2.74. Excel already do the approximation, okay, depending on the number of decimals that you want to show up. So actually, just to show you, if I had 3 decimals, I would have got 2.738, but because I only wanted 2, Excel approximated that to 2.74. Excel will do the calculation with the whole digits, you know, with the whole value, with all the extra digits, but for what is shown, Excel do the approximation. So 2.738 becomes 2.74. You know, 5 and above, you increase by 1. Below 5, you just keep the decimal as it is instead of increasing by 1. So that's what you get. Now, for position, although absolute uncertainties are fine, values are not fine. We need, for the first 5 marks, a position that has 2 decimals. So let's increase that number of decimals. And for the last one, 6 meters, that should be 6 point something. And actually the measure was 6.0. So here you go. All right. So that's for the table. Now it is probably formatted. Everything is fine. That would be ready to put into a lab report. What is missing is actually the numbering of the table and its title, which you would put into the lab report. You know, you would say table number 1, and then you would give a title like something that explains the purpose of this table, maybe something like measuring the velocity of a ball rolling on the floor on, I don't know, on Thursday, September the 5th, for class 006, maybe. Okay, something like that. So, all right, so that's the end of the first part. In the second part, I'm going to explain how to graph based on this data that you have in your table. Okay, so see you soon.